In this section, we're diving into one of the foundational pillars of penetration testing, reconnaissance and enumeration. As penetration testers, understanding these concepts is crucial because they set the groundwork for everything that follows. First, let's get an overview. Reconnaissance and enumeration involve collecting as much information as possible about the target environment. This phase is critical as it helps in identifying potential vulnerabilities and understanding the network layout and the systems in place. The importance of these steps in penetration testing cannot be overstated. Conducting thorough reconnaissance enables you to craft more effective attacks and provides a clearer picture of what you're dealing with. It lays the foundation for all subsequent stages in your penetration test. We'll delve into the primary objectives during reconnaissance and enumeration, such as gathering domain-related information, discovering network ranges, identifying active machines, and uncovering open ports and services. Additionally, we'll explore key techniques you can employ to extract this information effectively. These might include tools, scripts, and methodologies that have been proven effective in diverse scenarios. Now, let's proceed to the next slide where we distinguish between active and passive reconnaissance, understanding their definitions, the differences, and specific examples of when and how to use each method. As we move on from the introduction to reconnaissance and enumeration, let's delve deeper into the methods we employ during this phase. It's essential to distinguish between two primary types of reconnaissance, active and passive. Active reconnaissance involves direct interaction with the target system, allowing us to gather information through methods such as port scanning using tools like Nmap. This type of reconnaissance can produce a significant amount of information quickly, but comes with the risk of detection, as it involves engaging with the target's systems. On the other hand, passive reconnaissance involves collecting information without direct interaction with the target system, thus minimizing the risk of detection. Examples include gathering data from social media or public databases, where we can look for any information that the target has inadvertently made public. Understanding the differences and knowing when to use each method is crucial. Active methods are often used when there is a need for detailed information about the system, whereas passive methods are ideally used in the initial stages of testing to avoid detection. In the next slide, we will explore open source intelligence, OSINT, an invaluable component of the reconnaissance phase. We will cover various techniques and tools used in OSINT and discuss its importance in gathering comprehensive information about the target. On this slide, we will delve into the concept of open source intelligence, commonly referred to as OSINT. To begin with, OSINT encompasses all of the information that can be legally collected from free, public sources about an individual or organization. This includes a wide range of data points from online databases, news articles, public records, and even social media platforms. OSINT techniques have evolved significantly, and there are several advanced tools that facilitate this data collection. Some notable tools include Maltigo for mapping relationships and connections, the Social Engineer Toolkit, SET, for automating social engineering tasks, and many more. Understanding and mastering OSINT is crucial in the reconnaissance phase of ethical hacking and cybersecurity investigations. It enables the identification of significant data that can define the direction of further probing activities. In the next slide, we will dive deeper into OSINT with a specific focus on gathering information from social media platforms. We will explore tools such as Maltigo and the Social Engineer Toolkit, SET, and illustrate some example commands, like using Maltigo to visualize social connections. On this slide, we're diving into the realm of open source intelligence, or OSINT, specifically focusing on social media. Social media platforms are treasure troves of information that can be leveraged for intelligence gathering. We can extract valuable data about individuals, organizations, and even trends. First, let's talk about the powerful tools available for social media intelligence gathering. Maltigo is a fantastic tool that allows you to map out social connections. With Maltigo, you can graphically link people, groups, and various social interactions, providing a visual representation of their relationships. Another essential tool is the Social Engineer Toolkit, SET, which is designed to perform advanced social engineering attacks, commonly used in penetration testing. For example, using Maltego, you could run commands to map social connections and gain insights into how individuals interact within networks. This can be incredibly useful during reconnaissance phases to understand the social dynamics within an organization or community. In the next slide, we will delve into gathering information from job boards, exploring how job listings can offer insights into a company's technologies and ongoing projects. Platforms like Indeed and LinkedIn are especially useful in this context. Stay tuned as we continue to explore the breadth of OSINT. In the previous slide, we delved into the world of social media platforms and how to gather valuable information using tools like Maltego and the Social Engineer Toolkit. We explored example commands to map social connections effectively. Moving on to this slide, we will focus on collecting information from job boards, which can be particularly revealing and instrumental in OSINT operations. Job listings often contain insights into a company's current technologies and ongoing projects, which can be highly useful. For example, platforms such as Indeed and LinkedIn are treasure troves for this type of information. By analyzing job postings, you can discern which programming languages, frameworks, and systems are being deployed, and even infer the structure and needs of the organization. Now, as we move forward to the next slide, we'll shift our attention to scanning code repositories like GitHub and GitLab. This can reveal exposed credentials and configuration files, providing another layer of valuable data for our OSINT activities. Stay tuned for specific commands and tools like GitRob that facilitate this process. On the previous slide, we discussed how job boards can offer valuable OSINT opportunities by providing insights into the technologies and projects a company is working on. We examined platforms like Indeed and LinkedIn for this purpose. Now, let's turn our focus to scanning code repositories. By gathering data from platforms such as GitHub and GitLab, you can uncover exposed credentials and configuration files, which could be used for further network penetration efforts. A practical tool for this task is Gitrobe, which helps in searching such exposed data. For example, bash tapper searching GitHub for exposed API keys, Gitrobe. Moving on to the next slide, we will delve into the domain name system, DNS. Here we will discuss DNS lookups and reverse DNS lookups, along with some essential tools like NSLookup and dig. Building on our exploration of code repositories as a source for OSINT, let's now shift our focus to the domain name system, DNS, as another powerful tool for gathering information. On this slide, we are discussing DNS lookups and reverse DNS lookups. DNS, or domain name system, translates domain names into IP addresses, which are easier for servers to understand. This can be highly useful in OSINT for various purposes, such as identifying the servers and services that a target is using. We'll be using tools such as NSLookup and dig for our DNS inquiries. These tools help with both forward lookups, converting domain names to IP addresses, and reverse lookups, converting IP addresses back to domain names. For example, the command for performing a DNS lookup using NSLookup is straightforward: NSLookup example.com. This command allows us to query the DNS records of example.com and retrieve the related IP address or addresses. Knowing how to perform these lookups will greatly enhance your ability to map and understand your target's online presence. In the next slide, we'll delve into working with cached pages, exploring tools and techniques for leveraging archived information. Let's take a closer look at how cached data can be utilized for effective OSINT. Building off our previous discussion on DNS lookups and the useful tools like NSLookup and dig, let's delve into another valuable OSINT technique: leveraging cached pages. When investigating online, cached pages can be a goldmine of information, especially if the original pages have been altered or taken down. Utilizing cached pages allows us to retrieve and analyze previously available content. Two primary tools we can use for accessing cached pages are Google Cache and the Wayback Machine. Google Cache gives us quick access to the most recent snapshot of a web page, while the Wayback Machine allows us to look at a website's history by archiving multiple versions over time. For example, you can use Google Cache by entering cacheexample.com into the Google search bar to see the most recent version saved by Google. Similarly, the Wayback Machine at archive.org enables you to explore historical snapshots of any given website. In our next slide, we'll cover OSINT techniques related to identifying cryptographic flaws, and we'll discuss tools like SSLIs and OpenSSL. These tools can help us assess the robustness of SSL/TLS implementations on target systems. All right, continuing from where we left off with leveraging cached pages for information, let's now move on to identifying cryptographic flaws in OSINT. On this slide, we'll discuss how to identify weak cryptographic implementations in various systems. Identifying these weaknesses is crucial because they can expose sensitive data and make systems more vulnerable to attacks. Tools. We'll be focusing on two main tools here, SSLIs and OpenSSL. SSLIs. This is a fast and powerful SSL/TLS configuration analyzer. OpenSSL, a robust, full-featured open-source toolkit implementing the Secure Sockets Layer (SSL) and Transport Layer Security (TLS) protocols. Example commands. For instance, using SSLIs to check an SSL/TLS implementation, you might run the following command, sslis_example.com. This command will analyze the SSL/TLS configuration of the specified domain, checking for issues like weak cipher suites, expired certificates, and more. Understanding how to use these tools effectively will empower you to uncover and address cryptographic flaws proactively. In the next slide, we will delve into the use of leaked password databases for OSINT. We'll discuss websites like Have I Been Pwned and Dehashed, along with example searches. In the previous slide, we explored cryptographic flaws and how to identify weak cryptographic implementations using tools like SSLIs and OpenSSL. We covered example commands to check SSL/TLS implementations to assess the security of cryptographic protocols. Now, moving on to slide 10, we will delve into password dumps in the context of open source intelligence, OSINT. Using leaked password databases can be a powerful method in cybersecurity investigations. Websites such as Have I Been Pwned and Dehashed are invaluable resources for this purpose. These platforms allow us to search through vast collections of leaked credentials to assess if particular email addresses or passwords have been compromised. For example, using these websites, one could input an email address to check if it has appeared in any data breaches. This information can then be used to understand the scope and impact of specific breaches, as well as to protect users from further exploitation. Next, we will shift our focus to network reconnaissance in slide 11. Here, we will provide an overview of network reconnaissance techniques, discuss specific tools, and look at example commands, such as scanning a network with Nmap using the command nmap sp 192.168.1.24. This will help us to map out and analyze network structures, aiding in the identification of potential vulnerabilities. On the previous slide, we discussed OSINT and how to use leaked password databases to gather information. Websites like Have I Been Pwned and Dehashed were highlighted, and we saw some example searches you can use with these tools. Now let's move on to network reconnaissance. Network reconnaissance is a crucial part of understanding your target's network infrastructure. This slide provides an overview of the techniques and tools used for this purpose. One of the most common tools is Nmap. For example, if you want to perform a network scan, you can use a command like nmap.sp 192.168.1.024. This command will perform a ping scan across the specified subnet, helping you identify which hosts are active on the network. In the upcoming slide, we'll delve deeper into protocol scanning. We'll cover TCP and UDP scanning in detail and discuss tools like Nmap and masscan, along with example commands to illustrate their use. Continuing from our discussion on network reconnaissance, let's dive into protocol scanning specifically with TCP and UDP. This slide highlights the importance of understanding the different protocols you might encounter within a network. To perform a TCP scan, you can utilize tools like Nmap or masscan. Nmap is particularly well known for its extensive capabilities. For instance, you can execute a basic TCP scan with the following command, shell nmap-st 192.168.1.024. This command initiates a TCP connect scan, -st, on every host within the specified subnet, allowing you to identify open TCP ports. By mastering these tools and techniques, you can gain deeper insights into the network structure and behavior, paving the way for more advanced reconnaissance activities. In the next slide, we will explore the use of certificate transparency logs in reconnaissance, leveraging tools like CRT-SH and CertStream. These logs can provide invaluable information about SSL certificates, helping to uncover hidden assets and domains. Let's move forward to understand this concept in more detail. Now, moving on from protocol scanning, let's delve into the topic of certificate transparency logs, which is the focus of this slide. Certificate transparency logs serve as an effective tool for reconnaissance, enabling us to track and list all the SSL certificates issued for a domain. This bounty of information can be invaluable during the reconnaissance phase of a network security assessment. There are several tools designed to help with this. Two prominent examples are CRT.sh and CertStream. These tools allow you to pull data from certificate transparency logs, providing insights into new and existing certificates that belong to a target domain. By employing these tools, you can uncover subdomains and related domains that may not be immediately visible through traditional DNS enumeration techniques, making them powerful resources in your security toolkit. Let's discuss a couple of techniques. For instance, you could use CRT.sh to search for all certificates issued to example.com and its subdomains. This can reveal a wealth of information about the structure and points of presence of example.com. Similarly, CertStream provides real-time updates on newly issued certificates, which can help you stay abreast of any new infrastructure being brought online by the domain of interest. In summary, by leveraging certificate transparency logs through tools like CRT.sh and CertStream, you can significantly enhance your reconnaissance capabilities. Now let's move on to the next slide, where we'll explore the concept of information disclosure and techniques for identifying unintentional information leaks. In the previous slide, we discussed certificate transparency logs and how they can be utilized for reconnaissance using tools like CRT.sh and CertStream. We also went over some example techniques for leveraging these logs to gather information. Now, let's move on to information disclosure. In this section, we'll focus on identifying unintentional information leaks. Information disclosure can happen through various channels, and understanding these can help in both offensive and defensive security roles. We'll explore different techniques and tools that are commonly used to discover such leaks. Some example methods include scanning for publicly accessible files or using specific tools that can help in tracking down information disclosure vulnerabilities. By closely examining these inadvertent information leaks, we can better understand how sensitive data might be exposed and take measures to protect it. Next, we'll dive into search engine analysis and enumeration in the upcoming slide. Continuing our discussion from information disclosure, let's now delve into search engine analysis and enumeration. In this module, we will explore how search engines can be powerful tools for information gathering. Specifically, we'll look into using Google Dorks to uncover sensitive data that may be unintentionally exposed online. Google Dorks involve using advanced search queries to sift through data in a more targeted manner. For instance, you might use a command like cite example.com file type PDF to find PDF documents within a specific domain. Google Dorks can reveal a treasure trove of information, from hidden directories to confidential documents, all by leveraging the power of search engines. On our next slide, we will cover the essentials of network sniffing. We'll discuss tools like Wireshark and TCP dump and how to use them for capturing network traffic, ensuring you have a comprehensive toolkit for your information gathering needs. Continuing from our previous discussion on search engine analysis and using Google Dorks for information gathering, we now move on to network sniffing. In this section, we provide a comprehensive overview of network sniffing. Network sniffing involves capturing and analyzing packets traveling across a network. This can help in diagnosing network issues, detecting security breaches, and understanding the flow of data. The two primary tools we will focus on for network sniffing are Wireshark and TCP dump. Wireshark offers a graphical interface and is extremely powerful for deep packet inspection. On the other hand, TCP dump is a command-line utility that allows for quick and efficient packet capturing. For example, to capture network traffic on an interface named edeth0 using TCP dump, you could use the following command: bash TCP dump eth0. This command will start capturing all packets going through the ETH0 interface. In the next slide, we will delve into banner grabbing, explaining how we collect service banners using tools like Netcat and Telnet. We will also see some example commands to perform banner grabbing efficiently. Stay tuned. In the previous slide, we discussed network sniffing, examining how tools like Wireshark and TCP dump are used to capture and analyze network traffic. We also saw some example commands for capturing network traffic using TCP dump. Now, moving on to the current slide, slide 17, we are going to delve into banner grabbing. Banner grabbing is the process of collecting information about a service running on an open port of a remote system. This information typically includes details about the software version and the type of service running, which can be crucial for vulnerability assessment. To perform banner grabbing, we can use tools like Netcat and Telnet. Here's an example command using Netcat. Banner grabbing with Netcat nc example.com 80. In this command, nc stands for Netcat. The -v option is used to make the connection verbose, meaning it will provide more detailed information. Example.com is the target domain, and 80 is the port number for HTTP. This simple command establishes a connection to the specified port and can capture the banner information returned by the service. Next, we will discuss HTML scraping in slide 18. This involves extracting information from HTML content using tools like Beautiful Soup and Scrappy. We'll look into example commands for scraping HTML content, starting with Beautiful Soup. On this slide, we're diving into HTML scraping. HTML scraping is a powerful technique used to extract information from web pages. This can be particularly useful for gathering data from sites where an API might not be available or when dynamic content is displayed on the web page. To perform HTML scraping, popular Python libraries like Beautiful Soup and Scrappy are commonly used. On the slide, we have a brief example demonstrating how to scrape HTML content using Beautiful Soup. Here's a quick walkthrough. 1. We first import the necessary libraries, Beautiful Soup for parsing HTML and requests for making HTTP requests. 2. We define the target URL. Through using the requests.get method, we make a GET request to fetch the page content. 4. We then pass the retrieved HTML content to Beautiful Soup, specifying the parser. Finally, we use Beautiful Soup's methods to extract and print specific parts of the HTML, like the title of the page. This simple example can be extended to extract other kinds of information by identifying different HTML tags and attributes. In the next slide, we'll provide an overview of enumeration techniques, focusing on their importance in penetration testing and reviewing key objectives and methods used in the process. On slide 19, we delve into enumeration techniques, a critical aspect of penetration testing. Enumeration involves extracting more detailed information about the target system and network. This step is vital because it prepares the foundation for identifying potential attack vectors. Enumeration techniques can provide insights such as user account details, network shares, and services running on networked computers. These details are essential for creating an effective strategy for further penetration testing activities. There are several key objectives in enumeration, including identifying hosts on the network, mapping out the network infrastructure, and uncovering details about operating systems and service configurations. Techniques commonly used in enumeration vary widely, but can include querying services, scanning network ports, and probing for known vulnerabilities. As we move to the next slide, we'll explore a specific enumeration technique, operating system fingerprinting. This technique helps us determine the OS type and version running on target machines using tools like Nmap and Xprobe2. Remember, the more information we gather during the enumeration phase, the better prepared we will be to exploit potential weaknesses effectively and accurately. Let's delve into the specific techniques for identifying an operating system, commonly known as OS fingerprinting. In penetration testing, accurately identifying the target operating system is crucial because it helps in tailoring the attack vectors and choosing the appropriate exploits. On this slide, we'll cover some of the primary methods and tools used for OS fingerprinting. 1. Techniques for identifying operating systems. Passive OS fingerprinting involves analyzing traffic sent by the target without direct interaction, minimizing the risk of detection. Active OS fingerprinting requires direct interaction with the target by sending specifically crafted packets and analyzing the responses. To Nmap, one of the most powerful and widely used tools for OS fingerprinting. It sends a series of probes to the target and analyzes the responses to determine the OS. Xprobe 2, another robust tool focused on OS fingerprinting, which also uses ICMP probes to identify the operating system. Here's an example command for OS fingerprinting using Nmap. ESH OS fingerprinting with Nmap O192.168.1.1. This command initiates an OS discovery scan on the specified IP address. The NAJO option triggers the OS detection process, where Nmap sends various probes to the target to discern the operating system based on the responses. Up next, we will discuss service discovery. This step involves identifying the services running on the target system, which is essential for understanding potential vulnerabilities linked to those services. We'll explore the key tools and example commands used to perform service discovery. Stay tuned. Let's continue from where we left off on operating system OS fingerprinting. Now we'll shift our focus to service discovery. The objective of service discovery is to identify the various services running on a network host. This information is critical as it helps in understanding the attack surface and potential vulnerabilities that may exist within those services. There are several tools available for service discovery, with Nmap and Nessus being among the most commonly used. As you might already be familiar, Nmap is a versatile network scanning tool, and Nessus is a more specialized vulnerability scanning tool. For instance, you can use Nmap to perform service discovery by running the following command. --service discovery with Nmap nmap-sv 192.168.1.1. The -sv flag in this command tells Nmap to probe open ports to determine the service version information. This allows you to gather detailed information about the services running on a target, such as the software version and sometimes even the configuration. Next, we'll dive into protocol enumeration, where we'll learn how to enumerate network protocols to get a deeper understanding of the network landscape. We'll also see how tools like Nmap and Netcat can be employed for this purpose. Stay tuned. Continuing from our discussion on service discovery, where we use tools like Nmap and Nessus to identify running services, let's move on to protocol enumeration. In this slide, we're focusing on understanding network protocols that are being used in a given network segment. Much like service discovery, protocol enumeration is a crucial step in network analysis and vulnerability assessment because it helps pinpoint which protocols are in use, thus offering more insights into the network structure and potential entry points. Our primary tools for protocol enumeration are Nmap and Netcat. For instance, using Nmap, we can perform a comprehensive scan of a subnet to identify active protocols. Here's a practical example. Shell HAP protocol enumeration with Nmap nmap-st 192.168.1.224. This command initiates a TCP connect scan over the specified network range, providing detailed information about the open ports and the protocols associated with them. In the next slide, we will delve into DNS enumeration, where we will explore techniques to enumerate DNS records using tools such as DNSenum and Fierce. Keep these techniques in mind as they build upon the principles we've discussed here in protocol enumeration. Let's move forward. Slide 23 focuses on DNS enumeration techniques. DNS enumeration is a critical step in network reconnaissance and involves identifying DNS records associated with a target domain. By enumerating DNS records, we can uncover valuable information like the domain's IP addresses, mail servers, and other DNS entries that might be critical for further penetration testing activities. There are specific tools designed for DNS enumeration, and two of the widely used ones are DNSenum and Fierce. These tools help automate the process and make it easier to gather comprehensive data. For instance, if you want to use DNSenum to enumerate the DNS records for a domain, you can run a command like bash dnsenum example.com. Running this command will provide you with a list of DNS records associated with example.com, giving you a clear view of the domain's infrastructure. In the next slide, we will move on to discussing techniques and tools for directory enumeration, focusing on identifying hidden directories and files within a web application using tools like Dirbuster, and GoBuster. On the previous slide, we discussed techniques and tools for DNS enumeration, such as DNSNum and fierce, and provided example commands to perform these tasks. Now, let's move on to the current slide, which focuses on directory enumeration. For directory enumeration, we aim to identify directories and files that are accessible on a web server. This can often reveal administrative pages, login portals, and other sensitive information which might be otherwise hidden. Two common tools for this task are dirbuster and GoBuster. These tools utilize word lists to brute force directories and file names, helping us uncover hidden content. Let's take a look at an example command with GoBuster. Shell directory enumeration with GoBuster. GoBuster -u8code/example.com/path to /wordlist. In this command, -u specifies the URL of the target website, and -w points to the word list file that GoBuster will use to perform the enumeration. In the next slide, we will delve into host discovery, outlining methods and tools, such as Nmap and ARP-scan, that we can use to identify live hosts within a network. Moving on, in this segment, we will discuss host discovery. Host discovery is the process of identifying live hosts within a network. To accomplish this, we utilize several tools, with Nmap and ARP-scan being the most prevalent. For instance, if we want to discover hosts using an ARP-scan, we can use the command bash arp-scan-l. This command will perform a network scan, listing all of the hosts that respond to ARP requests within the specified network. It's particularly efficient for local network environments, since ARP operates at the data link layer, minimizing the need for IP routing. In the upcoming slide, we will delve into share enumeration, where we explore identifying and enumerating shared resources on a network using tools such as SMB Client and Enum4Linux. Let's proceed. Continuing from host discovery, now let's dive into share enumeration. On this slide, we're talking about enumerating shared resources within a network. This process is crucial for identifying shared directories and files that might be accessible on other systems. To accomplish this, we can make use of tools like SMB Client and Enum4Linux. Here's an example command using SMB Client to list shares on a remote system. Bash-share enumeration with SMB Client. SMB Client L192.168.11. By running this command, SMB Client will attempt to list all shared resources on the system at IP address 192.168.1.1. This information can be valuable in understanding the network layout and identifying potential entry points or data repositories. In the next segment, we will cover local user enumeration, detailing tools like Enum4Linux and RPC Client to identify users on a target system. Continuing our course from enumerating shared resources, let's now delve into the realm of local user enumeration. Local user enumeration is a vital step in information gathering during a penetration test, as it provides insights into the user accounts on a target system. Two versatile tools often used for this purpose are Enum4Linux and RPC Client. For example, using Enum4Linux, a typical command to enumerate local users would look like this. Plaintext local user enumeration with Enum4Linux. Enum4Linux-u 192.168.1.1. This command queries the target IP 192.168.1.1 for a list of local user accounts, leveraging the capabilities of the Enum4Linux tool. It interacts with the SMB protocol to retrieve detailed information about the system's users. In the next slide, we will move on to email account enumeration, where we will explore techniques and tools such as the Harvester and Hunter.io for discovering email accounts associated with a specific domain. On slide 28, we move towards email account enumeration. This is a crucial step during an assessment, as identifying valid email addresses associated with a target can be a stepping stone to various further exploits, including phishing attacks. To achieve this, two primary tools you can utilize are the Harvester and Hunter.io. These tools are effective in gathering email addresses from various public sources like search engines and online databases. For instance, using the Harvester, you would execute a command such as shtheharvester-d example.com-b Google. Here, -d specifies the domain to search within and -b specifies the data source. In this case, we are using Google as the search engine. The Harvester will then compile a list of email addresses associated with example.com. Hunter.io, on the other hand, is a web-based tool that can also be used to find email addresses by searching through databases and online resources. Having discussed email enumeration, in the next slide, we will focus on wireless enumeration, where we'll cover the tools and commands used to enumerate wireless networks, effectively assessing another attack surface. Continuing our course on enumeration techniques, let's move on to slide 29, which focuses on wireless enumeration. Here we delve into methods for enumerating wireless networks, a crucial task for understanding the wireless landscape of a target environment. Two commonly used tools in this domain are AirCrack-NG and Kismet. AirCrack-NG is a complete suite of tools to assess Wi-Fi network security. An essential command for network enumeration within this suite is aerodump-ng. By running the command aerodump-n-0, we can capture raw 802.11 frames, allowing us to gather information about nearby wireless networks such as SSIDs, BSSIDs, signal strength, and encryption types. Understanding the details of the wireless networks around us helps in identifying potential vulnerabilities or misconfigurations that might be further exploited in penetration testing. In the next slide, we'll cover permission enumeration, focusing on how to enumerate permissions and access levels using tools like access.txt and relevant Nmap scripts. Moving on from wireless enumeration, let's dive into permission enumeration. This slide focuses on the essential task of enumerating permissions and access levels across your systems. Properly understanding and documenting these permissions is crucial for identifying potential security gaps and ensuring that users have only the necessary access rights. The tools that are highly effective for this task include access.chk and Nmap scripts. Access.chk is a powerful command line utility from sysinternals that helps you investigate the access permissions of files, folders, registry keys, and Windows services. A simple example command to enumerate permissions for a specific user is permission enumeration with access.chk, access.chk.exe username. Additionally, Nmap scripts can be used to gather open ports and services information, along with associated permissions. In the next slide, we will explore the enumeration of sensitive information such as cloud access keys, passwords, API keys, and session tokens. Understanding how to identify and secure these elements is vital for robust security practices. Stay tuned as we uncover the strategies and tools suitable for secrets enumeration. Now that we've explored permission enumeration with tools like access.chk and Nmap scripts, let's move forward to another critical aspect of security assessments: secrets enumeration. On this slide, we'll delve into the techniques for identifying and enumerating sensitive information, such as cloud access keys, passwords, API keys, and session tokens. Understanding where and a search for these secrets is essential for both pen testing and securing your environments. During this section, we'll cover various methodologies and tools used to unearth these types of secrets, allowing you to better protect or audit your infrastructure and applications. In the following slide, we will see some example commands, such as using trufflehog to find AWS keys in a code repository. This will give you practical know-how to apply these enumeration techniques in real-world scenarios. Let's dive in. Slide 32 provides practical examples of commands you might use for secrets enumeration. As we delve into the specifics, let's consider the scenario of searching for AWS keys within a code repository. Here's a command example using trufflehog. Trufflehog-regex-entropy equals true, github.com/example/repo. Trufflehog is a very effective tool when it comes to identifying high-entropy strings that are likely to be sensitive information such as AWS keys, passwords, and other API keys. By running this command, you can scan the specified GitHub repository for these secrets. The -regex flag enables regex-based searching, and -entropy equals true allows the detection algorithm to look for strings that exhibit high entropy, which is a common characteristic of keys and tokens. In the upcoming slide, we will shift our focus to attack path mapping, leveraging tools like Bloodhound and Maltego to map potential paths for compromise. Continuing from where we left off, on the previous slide, we covered how to use Trufflehog for finding AWS keys in a code repository. Now let's move on to attack path mapping, which is crucial for understanding potential vulnerabilities and how they can be exploited. On this slide, we have the tools Bloodhound and Maltego listed. These tools are incredibly powerful for mapping potential attack paths within a network. Bloodhound, in particular, is widely used for Active Directory enumeration and can identify the shortest path to a target. For command line usage, you can run Bloodhound simply by executing Bloodhound after its setup. This will start the UI for you to begin importing data and analyzing the potential attack vectors inside the network. In the next slide, we'll talk about techniques and tools for enumerating web application firewalls, such as YFW0F and Nmap scripts. Stay tuned for some useful example commands. In the previous slide, we explored attack path mapping, focusing on how to map potential attack vectors using tools like Bloodhound and Maltago. We examined the example command for Bloodhound to give you practical insights into attack path identification. Moving forward, we're now on slide 34, focusing on Web Application Firewall, or WAF enumeration. Enumerating WAFs is a critical step in understanding the defensive mechanisms in place that might prevent an attack. Tools like YFW0F and specific Nmap scripts can be highly effective for this purpose. For example, you can use YFW0F with a simple command such as bash yfw0f/example.com. This command helps you detect and fingerprint web application firewalls, giving you valuable information on the layers of defense protecting a web application. In the next slide, we'll delve into web crawling, where we will discuss techniques and tools such as Scrappy and Burp Suite to help you systematically explore websites for vulnerabilities. Stay tuned for practical commands to get you started with web crawling. Now that we've covered techniques for enumerating web application firewalls, WAFs, and the tools you can use, such as YFW0F and Nmap scripts, let's move on to the topic of web crawling. On this slide, we will discuss the methods and tools utilized for crawling websites. Web crawling is essential for gathering information about a website's structure, content, and exposed endpoints, which can be beneficial for both offensive and defensive security strategies. Two popular tools for web crawling are Scrappy and Burp Suite. Scrappy is a powerful open-source crawling framework written in Python, and Burp Suite is an integrated platform for performing security testing of web applications, which also includes web crawling capabilities. Here is an example command to get you started with Scrappy. Bash tap web crawling with Scrappy, Scrappy start project example. This command initializes a new web crawling project named Example. From here, you can customize your project's settings and develop specific spiders to target and extract the information you need from a website. On the next slide, we will delve into manual enumeration techniques, focusing on manual approaches such as checking robots.txt, sitemaps, and platform plugins. These manual techniques can often uncover specific details that automated tools might miss. Continuing from our discussion on web crawling, let's delve into manual enumeration techniques. While automated tools like Scrappy and Burp Suite are invaluable, manual enumeration can sometimes uncover nuances that automated tools might miss. In manual enumeration, we start by checking standard files that might reveal critical information about the website's structure and server configuration. For instance, examining the robots.txt file and the sitemap can provide insights into which parts of the website are meant to be publicly accessible and which are intentionally restricted. Additionally, identifying platform plugins can help us understand the underlying technology stack, which can be useful for targeted information gathering or vulnerability assessment. Next up, we will look at some example commands to perform these manual enumeration tasks. Continuing from our discussion on manual techniques for enumeration, let's delve into some example commands that you can use during your reconnaissance phases. On this slide, we have an example of how you can check the robots.txt file on a target website. The command showcased here is checking robots.txt curl example.com/robots.txt. Using this curl command, you're requesting the robots.txt file from the website. This file can reveal directories and files that the website owner has opted to hide from search engines, which can be valuable in your information gathering process. In the next slide, we'll move on to summarizing all the reconnaissance and enumeration techniques we've discussed so far and highlighting their importance in penetration testing. We'll also discuss the next steps and further learning opportunities to deepen your understanding. So let's proceed. In this final slide, we wrap up our discussion on reconnaissance and enumeration techniques, which are essential stages in penetration testing. We've looked at various tools and commands, including our last example on checking the robots.txt file using curl. These techniques allow us to gather crucial information about our target systems. To summarize, reconnaissance helps us map out our target's landscape by collecting as much data as possible without engaging directly with the systems, whereas enumeration dives deeper to extract detailed information using more interactive methods and tools. Understanding these processes is critical because they set the stage for identifying potential vulnerabilities that can be exploited in later phases of penetration testing. Moving forward, deepen your knowledge by practicing these techniques on your own lab environments and stay updated with the latest tools and methodologies in the field. Your next steps might include advanced courses in vulnerability analysis, exploitation, and post-exploitation tactics to enhance your skill set further.